Hi, good morning, everyone. Welcome to the first international webinar on body composition, organized by the Malaysian Society of Body Composition. We are still waiting for more attendees to actually join us. According to our registration, there were more than 1,000 that has registered for our webinar. Okay, so we're still waiting for more people to actually come in. So in the meantime, you may, we are also sharing the abstract and also the program flow for the webinar for today. You may refer to the shared screen that you can see on the slide. Yeah. So do bear with us for a while before we begin. Yeah. At the moment, we have 548 participants that has logged in WebEx. Yeah. We're also on YouTube and also Facebook. Yeah. So we're still waiting for a while, and we will begin shortly at around 9:50 a.m. So according to some updates here from our team, there's a total of 58 that is actually viewing from YouTube. Yeah, 17 participants from Facebook. So yeah, we have quite a number actually. Yeah, it's been overwhelming in terms of response. That's really something that we're looking forward to today. Hello, everyone, and welcome to today's first international webinar on body composition, organized by the Malaysian Society of Body Composition, in short, MSBC. Yeah, my name is Serintong, and I'm actually the MC for today. I'm a nutrition with wellness lecturer from UCSI University, and also the Assistant Secretary of the Pro Tem Committee of MSBC. Now, for those who do not know about the society and would like to know more about it, you may log on to the website at www.msbc.org.my or follow us through Facebook. Now, while waiting for the rest of the attendees, a brief abstract of the presentation for today and also the program flow for the event has been shared. Now, according to our registration, we have more than 1,000 that registered for the webinar. Currently, on the WebEx platform, we have a total of 576 participants, yeah? And on Facebook, there are also more, yeah? Same goes to the YouTube. I believe there are more than close to 100 participants also there, yeah? So do take note that today's webinar is also accessible through Facebook and YouTube Live. You may refer to the chat box for the Facebook and also YouTube link, which will be shared shortly. Yeah? Now, before we begin, I would like to share some housekeeping matters with regards to the webinar. Now, if you have any questions for the speaker later on, yeah, please feel free to send it through the Q&A tab at the bottom of the WebEx to all panelists instead of the speaker. You may also type your questions at the comment section for Facebook and attendees. Please take note that we will only be taking questions between 10:15 a.m. to 10:55 a.m., which will be answered at the end of the session, yeah? However, do take note that due to the time constraints, we may not be able to answer all questions, yeah? So we will try our very best to answer and also to get the remaining questions answered after the webinar and be made available through the Society's website. Lastly, we would like to encourage you to share today's webinar with your social media and also social network, yeah? So you can share the social sharing icon at the top right of the player to post this webinar directly on Twitter and also on LinkedIn. Yeah, so that is a very short video introducing the Malaysian Society of Body Composition and what we do. Yeah. At the moment, we have a total of 584 participants, yeah, on WebEx and also many more, yeah, on Facebook. So according to the program, okay, the next that's coming up is actually a welcome remark from our very president, yeah, our very own president of MSBC, Professor Dr. Chan Yuk-man. Okay, we will wait for a short while more, okay, before we begin, yeah? Before I begin introducing Professor Dr. Chan. So Professor Dr. Chan Yuk-man, who is the MSBC president, yeah, is a clinical dietitian at the Department of Nutrition and Dietetics. Faculty of Medicine and also Health Sciences, Universiti Putra, Malaysia. She is currently leading the Research Center of Excellence, Nutrition and Non-Communicable Diseases, or in short known as RCOE-NNCD, UPM. Now, without further ado, let's welcome Professor Dr. Chan Yokman to give her welcome remarks.
Thank you, Dr. Shariff, for the nice introduction. Ladies and gentlemen, good morning and hello to everybody. We welcome you aboard to our today's seminar, the body composition and measures, pros and cons, what lies underneath. Now, ladies and gentlemen, before we start our webinar today, let's give me some time to introduce the newborn in Malaysia, the Malaysian Society of Body Composition. Now, the idea of setting up the society was moved by the overwhelming positive feedback from the first scientific seminar on body composition and nutrition organized by Universiti Putra, Malaysia on 5th July 2019. Since then, a series of discussions took place to ensure that the establishment or the formation of the society is able to benefit all members of the society as well as the nation. Finally, MSBC was born on the 18th March 2020, which actually marked an important milestone in the history of body composition in Malaysia. I am honored to share with you, these are the strong people behind the scene, and none of us, which is actually mixing up of a good combination of dietitians, nutritionists, clinicians, sports scientists. Okay, now we are aware that the importance of body composition in the assessment of overall nutritional status of an individual. Despite a number of research has been conducted on body composition, however, we think there is a need to have more work on the body composition. For this, the society, MSBC, was established to achieve the four main objectives as what you can see in this slide. In order to achieve the objective, a series of activities are planned for this year until 2021, which include the webinar we have today with our distinguished speaker and guest from New Zealand, Prof. Elaine Raj. All right, not to forget, in December 2020, we will be having our training workshop on body composition with the aim to enhance the skills and body composition techniques for better assessment and monitoring. Following on with that, there will be a technical workshop on body composition in the first quarter of 2021. We target to have it organized sometime between March and April, so please stay tuned with us. Now, acknowledging the importance of body composition, I believe you agree with me, more people are needed to contribute to this aspect. For that, on behalf of the committee, I welcome you to join our first AGM and scientific updates, which are scheduled to be on 9 October 2020. So please mark your calendar. You may visit to our official website, the Malaysian Society of Body Composition, at www.msbc.org.my for more information, or you may contact us via secretary email address. I would like to thank every one of you. Now, without further ado, please join me to welcome my good friend, Professor Dr. Sazlina. She is the moderator for Prof. Elaine's talk today. Without further ado, Prof. Sazlina, it is your time. Thank you.
Thank you, Prof. Chan. Good day, everyone, and welcome to today's first international webinar on body composition and measurements, pros and cons, what lies underneath. I'm Sazlina Shariff, and I'll be your moderator for today. I'm a family physician from UPM and the treasurer of the MSBC's Pro Tem Committee. Today, I am pleased to introduce you an internationally renowned research leader, Professor Emeritus Elaine, from the Auckland University of Technology and a member of the New Zealand Order of Merit. She has diverse research expertise in the measurement of body composition, energy expenditure, physical activity, nutrition, food security, and risk factors for disease. She has authored more than 180 publications. Her research involvement includes Energize in preschools and primary schools, reaching more than 60,000 children. She has conducted longitudinal studies of the health, growth, and dietary patterns of children whose mothers had gestational diabetes, children in the Pacific Island Family Study, and children in Pune, India. She is an associate investigator with the RIDEP Center of Research Excellence in Food and Related Sciences, a scientific director of the New Zealand Nutrition Foundation, and the deputy editor of the British Journal of Nutrition. With this, I welcome Prof. Elaine, and over to you. Thank you.
Thank you, Sazlina, for the introduction. I'm just working out how to share my screen. Is that showing now? Can you give me a thumbs up of, oh, gosh, wrong one, sorry. Just looking for the chat. Could somebody please tell me if I am broadcasting?
Yes, we can see your slide. Yep.
Excellent, thank you. I thought once I went to the slides, I lost everything. Right. Selamat pagi. Kia ora. It's a privilege to be able to be asked to talk with you today, to share my knowledge and experience of the measurement of body composition. Hopefully at the end of this session, you will have a better understanding of the ins and outs of body composition measurement. Yeah, that's better. Right. To me, the human body is the most amazing construction. Structure and function integrate perfectly. On the right in blue, I show different ways of measuring the composition of the body. On the left in orange are factors that influence body composition. And finally, I will talk about relationships between these factors and body composition. I'd like to start with talking about where the atoms and molecules in our bodies come from, and that is food. We come in all shapes and sizes, and that's determined by our dietary patterns as well as inheritance. But our bodies are basically what we eat and do. Dietary patterns, different ways we eat, are combinations of the quantity, quality, and diversity of the foods that we eat. Where does food come from? The food ecosystem. To grow healthy plants and animals, you need water, Water is arguably the most important nutrient and should be included with all discussions of food. As well as water, you need soil, good soil, and the minerals in that soil. In addition, you need carbon dioxide, nitrogen, and oxygen. And then very importantly, the sun. All energy comes from the sun, so that you get the warmth and the light from there. All very relevant in these days where we consider more climate change and sustainability. And finally, like people, we need healthy seeds to grow healthy plants and healthy people. Now, back to the elements that the body is composed of. In order, we're mostly composed of oxygen. In this 50 kilogram model of a human, 30 kilograms is oxygen. We're also composed of carbon, around about 11 kilograms of equivalent of soot, hydrogen and nitrogen. But it's important to understand these molecules because one of the important ways of measuring body composition and metabolism is to use stable isotopes. These are naturally occurring isotopes of the elements, but they have 1 or 2 extra neutrons in their nucleus, and therefore that makes them heavier. They are not radioactive, but they are very useful for measuring the body composition and compartments within the body, and also metabolism, because they can be used as biomarkers on many different molecules. But going back to the food, we eat food and not nutrients. So when we're talking about body composition, we have to talk about diet as well. And I'd just like to share with you my 4 F's mantra. We should be eating wholesome foods in sensible combinations for the best of health. But there's 4 things, including food, that we need for best health. And the evidence for this comes from the blue zones where people live to be well and happy and active well into their hundreds. So the first one is food and the wholesome food. The next one is feet and physical activity. We need to be moving regularly. The third F is for fingers, and that's a negative one. We should not be smoking. And finally, fellowship. Now, fellowship is a big category because it's about socialization, which comes with food, but it's also about lack of stress and good sleep and lack of disease as well. So the 4 F's to look after ourselves: food, feet, fingers, and fellowship, which includes sharing on occasions such as this. Now, we do not sit still. We are growing. Right from the moment the egg meets the sperm and a new individual starts, there is rapid division of cells. So on the x-axis of this slide is the life course, and on the y-axis is increasing disability or ill health or not functioning so well. You could put many different things on the y-axis. When we're first conceived, we have a small fixed genetic contribution to risk for disability. The younger we are, the earlier the intervention is applied, will have a bigger effect on reducing risk. But it's never too late to change. And even in later life, there will be a small impact of intervention. So It's never too late. But every day matters, and some matter more than others. And the first 1,000 days are critical to the well-being of a child, and that starts, again, from conception. That time when cells are dividing so rapidly is a time to shape the health of the child. So it should be a focus of all governments to look after the young better, and the parents and the families. Now, the time course is of interest as well, and this is data from New Zealand, which has taken all the times that body weight and height were measured, BMI calculated, and obesity and overweight determined. This dark line here that goes across the middle and is relatively horizontal is my father's generation, those born before the 1930s. And the prevalence of obesity in that cohort, even when measured in 2014, was very low compared to what it is now. So it was around about 20%. And those born in the 1960s, you can see that the prevalence of obesity was up to 38%. And those born more recently in the 1980s here, which is my children, you can see the rising prevalence of obesity with age. So it starts early, but the incidence keeps increasing each year as we age. And so the older you are, the more likely you are to be obese. And I'm sure that's true for all the countries that we represent. There is a quadruple burden of malnutrition in the world. It's usually defined by BMI, but you can have bad or malnourishment at any size. Now, obesity and overweight are probably the ones that are most talked about, but not always recognised as malnutrition, unbalanced nutrition. Then there's underweight and stunting, which is still prevalent. But another form of malnutrition, which now we're talking about more, particularly with COVID, is food insecurity, not being able to access the quantity and quality of foods that we need for good health. And finally, there is hidden hunger, which is very high in all countries. We just don't always measure it. An example of hidden hunger would be vitamin A deficiency. Another example would be vitamin D insufficiency or zinc deficiency. So these are all forms of malnutrition, but you don't necessarily see it just by looking at a person and measuring their height and weight. You have to look at the whole person. When we assess the body, we usually have to compare it to something else. So there's ratios and relativity. One of the best indicators I like, particularly for when working with the community, is that you should make your waist half your height. Well, that's the challenge. So it applies for children and adults that a healthy waist size should be half your height. And you don't even need measurements for that. You could just use a piece of string, cut it to your height, fold it in half and see if it'll go around your waist. The other ones are waist to hip ratio, which can also be an indicator of risk, but doesn't apply to all populations. The subscapular to triceps skin fold ratios is another way to measure central obesity on the surface, as it were. Stunting is relative to other measures, and in particular, the chart that you see here, like the BMI for age in girls, shows how you compare to not necessarily a normal population, but a population that is set in time and you can refer to. So measurements were done on many people, and the assumption was that there would be a normal curve, as shown in the middle graphic. And so the mean or median would be the 50th centile, which is also equivalent to a Z-score of 0. And then you have the centiles that go out. So it tells you how you compare to 100 other people spread evenly across the representative range. And that is how obesity and overweight get defined. Not necessarily on risk factors, but compared to the rest of the population. So it's very useful for monitoring populations using centiles and Z-scores, but it's not necessarily applicable to an individual, as my next slide will show. So here we have two lots of children. The one on the left, the group on the left, has a weight of 25 kilograms, a height of 110 centimetres, and a BMI of 20.6. The ones on the right weigh twice as much, 50 kilograms. They are taller, not twice as tall, because of course BMI is divided by height squared, but their BMI is pretty much the same. So if you just use the BMI scores for that, or centiles, same age, same BMI, same centile, and same Z-score for BMI. So that's why you must be looking at the individual measures of height and weight, and actually looking at the individual child as well. So now I want to talk about methods of measurement. I'm going to talk a bit more about BMI and anthropometry, bioimpedance analysis, and the two-compartment model, the most simple ones. Because really, when you're measuring a lot of people, it's better in terms of time and money to use the most simple measures that you can. Oh, now I've lost my mouse. Oh, sorry about this. The mouse seems to have disappeared. There it is. Right. So again, looking at the body simplistically and pretty well chemically dividing it up, we have, if you dissolved yourself in ether, and this has only been done for around about 12 cadavers ever in the world, we have a proportion of that body that chemically is fat, but that includes the fat that comes from the phospholipid membranes that surround every cell. So some of that fat is storage and some of that is functional fat. Then we have bone mineral content, which is basically calcium, which only constitutes a kilogram or so of our body weight, but it's still important. Then there is protein, the building blocks of our cells and functional, and then there is water. The number of times I have been told that the body is 80% water. It cannot be, because there is two compartments, fat mass, which by definition contains no water, and fat-free mass, which is all the rest, and together they add up to body mass. So the fat-free mass is 73.4, or around about 73% water. So you could never be more than around about 70% water, and that would be extreme because you'd have very, very little fat then. But again, here's water, again, most important part of our bodies. Now that water is what bioimpedance measures, because bioimpedance is putting an alternating current through the body, a very, very small one, less than what you get if you connected yourself to a torch battery. And that it's an alternating current, so that means it has the properties of reactance, impedance, and resistance, which are related in a mathematical way, expressed by a triangle and Pythagoras' theorem, and then the phase angle. Now, if the frequency of the electrical current is at 50 kilohertz, then it will go straight through all the water in the body. But the resistance in the other two quantities will depend on the amount of water in that body, the amount of fat-free mass, and also the dimensions of the body, how short and wide, or how long and narrow the body is. So that's why after you've done those measurements of resistance, you take the height of the body squared, divide it by that resistance, and it's proportional to total body water. But to convert it to fat mass or fat percentage, you will need a measurement of the actual body composition done by another method. And that's where the prediction equations that are often programmed into a bioimpedance meter are used. And of course, they have their errors as well. So it's very important to be aware which prediction equation is being used. And if you can, if you're buying bioimpedance equipment, to actually be able to measure the resistance and the phase from which the two others can be derived, you not only get a quality control measure, but you can also start working towards looking at your own relationships for the people that you are measuring, because populations are different. So body water can be measured by deuterium dilution. Deuterium is a molecule of hydrogen that, rather than just having one proton in its nucleus, it has a neutron as well, so it has twice the atomic weight. It is called heavy water when it's deuterated water because it is heavier, but it is not radioactive. But if a known amount of deuterium is introduced into the body, deuterated water, and then after a period of equilibration, a sample of water, such as saliva, plasma, or urine is taken, from the dilution, you can work out the quantity. So here's a very simple example. If you give a dose of 6 stars, so a dose has content, it doesn't have concentration. You put that into your unknown volume and shake it all about, and then you measure it and find that it's 6 stars per litre concentration, then you can work out that the volume that it was diluted in was 1 litre. So it's a very nice way of measuring body composition. Once you've got the amount of water, then you can derive the fat-free mass, and if you know the total mass of the person because you've weighed them, you can then work out what the percentage fat is. And I just saw a question pop up asking if the presentation will be available afterwards. Yes, I will PDF it and it will be able to be distributed. Now, other ways of measuring include body density. Underwater weighing used to be the way that was done, but I don't think it's done that often now. It's not very pleasant to put on a weighted belt and plunge underneath the water in a tank and be weighed while you're underwater. But there's a more recent innovation, the P-pod, or for adults, the bod pod, which is air displacement plethysmography, which takes practice saying, equivalent to underwater weighing, but you're looking at displacement. So the baby, in this instance, in the pea pod, got to be less than 7 kilograms, is weighed and then put inside a air-filled capsule where the amount of air displaced is measured through vibrating the air there. So a density is derived, and then again using conversion factors for density, you can work out the body fat mass and the fat-free mass of the baby. So very useful, and we've been doing a study of measuring babies pretty well as soon as they're born, then 6 weeks later, to look at an intervention during pregnancy. Another model of measuring body composition is by dual energy X-ray absorptiometry. Now, this piece of equipment comes in many forms, and it is very expensive, and it has been updated a lot since this picture was taken. But basically, a scanner goes from head to toe with a beam of X-rays going across the body and measuring the density of the body as related to 2 wavelengths of X-ray. And that gives a picture like this. You don't need to take your clothes off to have one of these scans, but the software takes away any covering you have and will show the presence of the bones and muscle and fat. Fat comes out as darker, muscle and intra-abdominal organs come out as varying shades, and the brain is a black box because it's covered by bone, and you can't see through that to see really how much fat is in your head or whatever. So assumptions are made. But you do get 3 compartments with this: fat, lean, and bone mineral. And lean plus bone mineral make up fat-free mass. So that's the 2-compartment model. And here is what it would look like on the screen. And once again, like those growth charts we were looking at before, we have charts that have looked at how it changes with age. And for this one, it is bone mineral density, which is grams of mineral per centimetre squared of the scan. And you can see if this is for a woman in particular, after the age of 50, there is a rapid decline in the amount of bone mineral content in the body compared to the reference that the manufacturers of the DEXA machine have used. But the advantage of these types of scan is then digitally you can cut it up. And with these red lines, after the person is long gone, you can divide the body up into arms and legs and head and torso, and it will repeat the analysis for bone mineral content, lean and fat for each one. But what I'm particularly interested in, and I'm sure you are too, is skeletal muscle mass. Now, the arms and the legs don't have any other organs besides skin, fat, bone and muscle. So if you just look at the arms and the legs, you can then derive the amount of skeletal muscle mass on the arms and legs. And skeletal muscle mass arguably is, particularly when you're exercising, is the most metabolically active tissue and very important for blood glucose homeostasis. The reason why we need to keep active, etc., to help balance the body, because we were built to move. Now, in probably one of my most cited papers, on that machine that I showed you earlier, almost 1,000 people were scanned, and the study was designed so that we got an even representation of, by ethnicity, decade of age, and also of varying sizes. So the 4 ethnic groups that are shown here are European, Maori, who are the indigenous people of New Zealand, Pacific, who are Pacific Island people coming from Samoa, Tonga, Cook Islands, etc. And they've come to New Zealand, so they're living in New Zealand, and Asian Indian living in New Zealand as well. Women are on the left and men are on the right. Now, the first thing you'll notice is body fat percent, which is on the y-axis, is much higher in women than men. That is normal. BMI is on the x-axis. So as BMI measurements increase, so does body fat increase. But it's not easily predictable. And you can see that, for instance, the Asian Indian, who are the blue points, each one of those is an individual, have the highest body fat percent in both women and men. And the Pacific Island people, who are in the green, which are light green, which I hope you can see, have the lowest. And there is a difference of more than 10 BMI points between the same percentage of body fat. Or if you look at this for the same BMI, for instance, for a BMI of 30, an Indian man would have a body fat of an Indian man would have a body fat of around about 30%, and a Pacific Island man would only have a body fat on average of about 20%. So you've got to be very careful about categorising an individual by BMI and saying that they've got too much or too little fat. There are many factors that can affect it. And then a little while later, student Jewel Wen scanned Chinese adults just aged between 30 and 39 years. This was for her master's. And they have been included in the dark green. So again, they're not the same as Asian Indian, and they're not the same as European. They're somewhere in between. So the Chinese living in New Zealand are different in their relationship between body fat percent and BMI to the other ethnic groups. So again, setting cut-offs that are fixed hard and fast is not a useful thing when you're looking at such a diverse, ethnically diverse population. And again, of course, gender or sex is probably a bigger difference than it is by ethnicity, so should always be considered. So now I'm looking at the appendicular skeletal muscle mass that was measured on those DEXA scans, just on the arms and legs, of course, the appendixes, and looking at it against age for these same people. So European are in the green, and by age, at all ages, their body has a higher percentage of skeletal muscle mass. In women, it's around about, for European, 28% of the body mass is muscle, and in men 34%. So men have a higher metabolic rate than women, and part of that is explained by the fact that they have more skeletal muscle mass. But you can see here for the Asian Indian, they have the least skeletal muscle mass. And rather than fat mass, the low skeletal muscle mass might explain better why they, Indian people in New Zealand, are at very high risk of having diabetes. And then looking at percentage body fat with age, skeletal muscle mass went down, but as with aging, the fat mass increases. But the advice is once you get to a certain age, in your 50s, it's not the best thing to lose a lot of weight. Having extra weight is really important for bone mineral density. The more weight the bone bears, the stronger it is, and also it gives a certain resilience as well. I think a focus on everyone trying to lose weight is wrong. There can be very healthy weights, which you still might have quite a large percentage of body fat, but it's the quality of the skeletal muscle mass that is probably more important. And this slide here shows the bone mineral density with age for these people that we measured. And you can see, particularly for women on the left, that bone mineral density declines in the 50s and the 60s, but it declines in men as well. So again, the importance of staying physically active and well nourished. Now, not only have we measured adults with DEXA, we've measured little ones. Now, this is a challenge. This study, called the Metformin and Gestational Diabetes, the follow-up study, was of children of mothers who had gestational diabetes and were treated with either insulin or metformin. So the mothers were treated with insulin or metformin while they were pregnant to help control their gestational diabetes, and we've followed the children to 2 years. And with the children, we looked at the amount of fat in the abdominal area, which you can see outlined here on the DEXA scan. It's by bony landmarks, the top of the iliac crests and the bottom of the ribs, and an equivalent height below the ischial tuberosities. So we're looking at the muscular area of the gluteal region. And the numbers weren't high. As you can imagine, it's quite hard to get children to lie still on a DEXA scan or even for a bioimpedance measurement. But you can see here that the Pacific, Indian and Chinese children had much higher percentage of fat in the abdominal area than Maori, European and the other ethnicities. Now, the numbers, as I said, were relatively small. There's only 21 European in this study, but the prevalence of gestational diabetes in Indian and Pacific and Maori, the numbers were too small there, is much higher than in European. So hence the greater representation in this study of women who had gestational diabetes. Overall in New Zealand, 1 in 10 women has gestational diabetes, which impacts on the composition of their children and their risk for diabetes in their later life. Now, going back to the adults, and this is women and men in that same study from the British Journal of Nutrition, what you can see here is that women and men who are European in the orange bars have less fat in the abdominal area than the other three ethnicities, Maori, Pacific, and Asian Indian. And they also have the lowest prevalence of diabetes. It's not causal, can't be shown to be causal by these studies, but it does show a pattern of body composition being associated with risk for diabetes. And this is just for the 30 to 39-year-olds, but again showing Europeans the lowest, and Chinese also have more central body fat than European. So European are the outlier. Now I wish to talk to you about Hattori charts and relationships between fat mass and fat-free mass. If you divide fat mass by height squared and fat-free mass by height squared, the sum of these two will equal body mass index. So fat mass index plus fat-free mass index equals body mass index. And it was Hattori in I think it was in the 1990s that actually first established this relationship. But I think it's a really good way of looking at the relationship between fat and fat-free mass. Now, this could be determined by bioimpedance measurements, it could be determined by skin folds, it could be determined by DEXA, it could be determined by deuterium dilution. So on this Hattori chart that I'm starting to build here, the fat mass index, that's fat mass divided by height squared, is on the y-axis, and fat-free mass index is on the x-axis. Now we're going to add the BMI isobars, because as fat mass index plus fat-free mass index equals body mass index, there's a constant relationship. So if fat-free mass index is 13 and fat mass index is 2, they total to be 15, and 3 and 12 are 15. So similarly, you can do a line for 17.5 of BMI or a line for 20 kilograms per metre squared. Now we're going to add the fat percentage bars, which aren't parallel. So again, you have to plot an equation to get these. We haven't put any data here yet. We're just showing the relationships between fat-free mass index and fat. So if you have a fat-free mass index of 13 and a fat mass index of 5.5, then fat percentage, body fat percentage is 30%. Hopefully you can see the system now. Now, these are children from Project Energize that were measured at ages 5 and 10. And of course, girls and boys are different, just like men and women are. So always consider them separately. The red is girls and the blue is boys. So this is for all the more than 1,000 children we measured altogether, aged 5 and aged 10. So you can see already the girls have more fat, a higher fat mass index than the boys, and the boys have more fat-free mass index compared to girls at both ages. We selected 5 and 10 as the ages to measure before the intervention was applied, because this is the time, 5 when they've started school and 10 when they're starting to enter into puberty as adolescents. So 2 very important times of change in children's lives. And here's what happened when we measured the same children 2 years later, at age 7 years and at age 12 years. Now you can see the girls increased their fat mass index more than the boys did. And the boys, particularly the 10 to 12-year-olds, increased their fat-free mass index more. They were a flatter trajectory. But as you increase each one, the other one must increase too as weight increases. So very dynamic. So this isn't what a BMI chart will show you, but by plotting these figures here, you can begin to see, because what we were looking for, and we didn't find, was children who had been energised, that we would hopefully see a reduction in their fat mass index and an increase in their fat-free mass index. But we weren't able to show that. But we were able to show that these same children, but now separated by ethnicity, there was no Pacific children in this sample. There was a third Maori and 2/3 European. This was in the Waikato area of New Zealand. You can see that the Maori, who girls on the left, boys on the right, and the Maori are the filled-in circles, are bigger at all ages and stages than the European. And they grow quite differently as well. And I've put the error bars on here. This is what is actually in the publication. But you can plot for a single child or for a group of children how fat mass and fat-free mass index change with time, which I think is particularly interesting, particularly if you're wanting to see the change with an intervention, or differences by ethnicity or by gender. Now, there's other more expensive methods, which I haven't used a lot because they are more expensive. You can only measure a few people. There's MRI, which you can measure the abdominal slice and see where abdominal or intra-abdominal fat or visceral abdominal tissue is. And that is of great meaning compared to the fat that might be found underneath the skin. So it's the ratio of the visceral abdominal tissue to the subcutaneous abdominal tissue is of great interest, because those slices that I took through the abdomen were not distinguishing between intra-abdominal and subcutaneous fat in the abdominal area. And there's also computerized tomography, CAT scanning, which shows also the distribution. And this is the same boy who lost 54 kilograms of body weight. You see he lost both visceral and also a very large amount of subcutaneous fat, which you can quite clearly see on the left in the picture, because it is able to be measured by skin folds, but you cannot see with unless you use X-ray eyes the amount of fat on the inside surrounding the organs, particularly the kidneys, which that suprarenal fat seems to be a particular risk factor. Quite different characteristics to the subcutaneous fat metabolically. And here's just a couple of anatomical pictures showing the vertical slice and also a horizontal slice where fat is in the human body across the abdominal area. Now, talking about New Zealand a bit, because that, of course, is what I'm most familiar with. We have a population of 5 million that is ethnically diverse. The European population is getting close to being less than half soon, and certainly with our young people. But 2/3 of our adults and 1/3 of our children are either overweight or obese, and 70% their waist to height is greater than 0.5. Now, why is this? Well, it is complex, and it's global and it's domestic, etc. But this map shows our socioeconomic deprivation areas. Where it is most red is the most deprived areas, not necessarily the most populated, but by area. So we have quite diverse socioeconomic status, and we also have very poorly nourished people. So talking about this deprivation, food insecurity, which is more and more important with COVID globally, back in 2014-16, households were surveyed to look for food insecurity, where questions such as, we eat less because of lack of money, variety of food is limited. Overall, 1 out of 5 households with children was judged food insecure. The least deprived 40% of households, only 10% of they were judged to be insecure. At the most deprived, 20%, this is the deprivation from the geographical areas, around about 35% were. So it's very clear that food insecurity increases with decreasing socioeconomic status. And obesity and overweight also increase with increasing food insecurity. So those of a healthy weight, 55% are severely to moderately food insecure, but amongst those obese, then you can see that the food insecure is almost double the food secure. And again, to show that the same graph, but looking at ages 5 to 9 and 10 to 14, you will note that the prevalence of obesity increases with age, and so does the prevalence of food insecurity, particularly amongst the overweight and obese. Now, the Pacific Island Family Study, which is a birth cohort born in the year 2000, I just want to mention a few findings from that. Where the Pacific Island people in the study come from is near to Auckland, which is on the skinny part of the North Island, towards the top of the North Island, and the Manukau Harbour, where any of you who have visited New Zealand would have flown in to Mangere Airport, which is on the coast here. And you can see this is a very highly deprived area because of the dark red colouring. Now, unfortunately, Maori and Pacific tend to be found in more deprived places than European, which doesn't mean European aren't deprived as well, but the proportion is higher. This is some pictures of the Mangere Harbour and the houses, so we don't have a lot of high-rise, and some shops from this area where, yes, there are fruit and vegetables, but the taro that is shown here is actually imported from the islands. All bananas in New Zealand have to be imported. We don't grow bananas in New Zealand, or pineapples. And there's a lot of sugary drinks here on these shelves. So the juxtaposition of the healthy foods and the foods that I consider to be junk and not worth feeding anyone. So the children have been measured at a number of age points from 6 weeks to 14 years, and what I'm going to show you, they now will be turning 21 next year, so they're still very young. And the measurements were made into critical periods of growth, but it was mainly a psychosocial study, which was measuring other factors other than body composition and diet. But I'd like to show you a plot of the children and their weights measured at the various stages. This is for boys, because boys and girls again are separated. it is not a CDC, this is not a World Health Organization chart. This is especially for Pacific children. So the 50th centile, or the 0Z score, goes through the middle of the children. So you can see here that at age 10, 3% are weighing more than 95 kilograms. That's at age 10. Okay, and we've been very careful about the actual age they were measured. We haven't rounded it to the nearest year. We've done it as a decimal of their actual years of life, as it were. And here, the blue line is the CDC median child. So almost 96% of these children are bigger than the median child in other population studies in the States. So they are growing very, very rapidly. And the girls show a similar trend, maybe not quite as heavy as the boys, but you can still see one up here at 95 kilos, another at 85 kilos. And quite a lot by age 10 are above 90 kilos. So again, their growth trajectory is very rapid. So when they turned 14, we looked back to see how these children had grown. Did they start large and grow slow? Did they start small and grow rapidly? We're looking at the trajectories, which is what we're looking at with the Hattori charts, but here we are looking at it just by weight, that very basic measure of body composition. So we approximated the trajectories by linear regression and looked at the intercept and slope, and in 204 children we did more studies, including taking blood samples to look at risk factors. And here is the patterns of growth. So we were able to look at lower body weight, early childhood, and grow slow. There was only 24 in that group. The 25 of them stayed pretty linear compared to the rest of the children in their cohort, and there's a few that had higher body weight in the early childhood and grew slow in relation to it. So we were able to look at different patterns of growth, a bit like looking at dietary patterns. And then we were able to look at the intercept and the slope, so where they started and how steep the trajectory was, and risk factors. And you can see here that particularly things or risk factors like C-peptide and insulin were related to the intercept and slope of growth. HOMA was, so risk for diabetes. The total cholesterol to HDL ratio was related. Leptin was related because they did have higher body fat. The urate was related, and the faster they grew, the higher the urate. Maori and Pacific, and in this case it is all Pacific, have a much higher prevalence of gout, and that's high uric acid, which is partly genetic, but partly related to diet. And we were able to show in the study consumption of sugary drinks and some of the liver enzymes were also related to the way they had grown since birth. So this was body composition and change in body composition related to rates of growth and risk for future disease. I just want to quote a few examples where functional and nutrient measures are associated with body composition measures, and these are ones that I have published about myself. The distance walked in 6 minutes is related to how long your legs are. We talk about the 6-minute walk test, but there's no adaptation for a person's height, or in particular, how long their stride can be. And so I think this is a very important factor to look at if you're doing a 6-minute walk and how far the person goes. So longer leg length means you can walk further, but higher body fat means you walk less. Uric acid is strongly associated with the amount of skeletal muscle mass, which is surrogate would be fat-free mass. So in these Pacific children, the urates in their blood were associated with their fat-free mass as well. And another study that I've just completed looking at vitamin A by measuring skin colour found that the lower vitamin A was present in those with higher body mass, which presumably means that they have more fat mass. So there's a greater quantity of fat for the same amount of the vitamin to dissolve in, so the concentration is less. I've also found the same with vitamin D. So people with a higher fat mass have lower fat-soluble vitamins. Now, does this mean that we need to make sure they have more? Finally, the last thing of looking at fat-free mass and also body mass is from the doubly labelled water studies that I've done. We also get a measure of water turnover. And from this, and each spot is an individual point, and I've just divided it into women and men, girls and boys, girls red, boys green. You can see that children, smaller people with lower fat-free mass have a lower turnover of water in litres per day. Now remember, it's not just what you drink, it's what is in the food that you eat, and also there is the water that you produce through burning glucose to water and carbon dioxide. So it's not just about how much you actually drink, but that can be a good measure and should always be considered in dietary surveys, how much water has been consumed. But you can see that for the adults, the women and men, the scatter is much higher. And I think on the right-hand side, you can see those of higher body mass, which are the women and the men. You will find that there is much more variation in the water turnover. And I think this is because we don't necessarily drink to thirst, we drink to social occasion. So, for instance, I have a glass of water sitting next to me at the moment, and if I'm at work, I go and have morning tea, I go and have lunch, I go and have afternoon tea, and I always have a drink then. And so many people now carry bottles of water around, and in hot countries, of course, you need to do it more. But are we drinking out of habit, or are responding to thirst? And maybe some of us could be drinking too much. Hyponatremia could be a very real problem. So finally, I'd like to end by asking the question, are we in balance? Are we taking in the right amount? How much are we putting out? The world is not in balance. We have got incredible climate change, and part of that, we're overpopulated. We have this terrible virus, COVID. At the moment, we have problems with food supply, etc. But the Gaia Hypothesis, which is about the Earth should be in balance, makes us think that it should be all the things that we do that will ensure a better future for our future children. So the goddess Gaia is on the right, representing the Earth, but the importance of the new child. And now I'm going to be happy to take questions if I can figure out how I can stop sharing my screen.
Thank you very much, Prof. Elaine, for such a wonderful and insightful sharing. So from what we have gathered today, that body composition changes with growth throughout one's life course. It varies according to age, gender, ethnicity, nutrition, activity level, environment, as well as genetics. Therefore, any interventions to reduce disability over one's life course should start even from conception. And as Prof. Elaine highlighted, to ensure that quadruple burden of malnutrition, in particular food insecurity and hidden hunger, should not be missed. Measuring height and weight is just not enough. Hence, a whole person approach through body composition assessment is imperative. And Prof. Elaine has also shared many assessment tools in assessing body composition and how this should be interpreted along with its advantages and disadvantages. In addition, she has highlighted how these tools are important in the assessment of nutritional state across different age groups and in the presence of comorbidities. So with this, allow me to share with you some of the questions from today's participants. Hold on, let me share the screen. Okay, the first question. Body composition changes with growth during critical periods in utero, baby, toddlerhood, and adolescence. What are the challenges expected measuring body composition during these critical periods? And what are the precautions to be taken on the interpretation of the fat-free mass and fat mass during this period? Over to you, Prof. Elaine.
Well, it depends whether you're doing research or clinical work. For research, the challenge is to have a really good research question thought out very carefully. And one of the biggest challenges I find is that you have to have a very clear research question that has to be worth doing, because we all have to get informed consent for measurements that we do. And unless it is worthwhile, it's not worth doing. Not only do we have to get informed consent, we have to be sure that we actually recruit and measure the people that we most want to, so that we're not just measuring those that like to take part in studies, but we're measuring across the food insecure, the more deprived people, the hard to reach populations where understanding more would make the best difference. So participation is tricky. For instance, with doubly labelled water and deuterium dilution, to get consent does require a lot of work, and to get ethical approval, to get the ethics committee on side first too. But if it means that you can get your own prediction equation and then apply it, say, using your own skin folds or bioimpedance, which are much quicker and less invasive measurements, it's well worthwhile. I wouldn't trust the manufacturers' equations that they have programmed into bioimpedance. I'd want to check them out for myself, and as I said in the presentation, actually measure the height squared to resistance ratio, so that you do have a measure that you could put into other equations, because the actual equations are published, but you do need to know those values. Certainly the smaller the child, and in pregnant women, it is a real challenge to measure the composition of the child. You can use ultrasound in utero. As far as using deuterium dilution in pregnant women, it's very difficult because of the mother and the baby's fluid compartments interchanging. The age in young people is very important because they can grow so much during a year. So never just record the age to the nearest year. Record it as a decimal fraction in years, and then you can better apply it on the growth charts or however you're looking to compare their growth rate or what's changing. And certainly with the 2-year-olds, there was a number of children we couldn't measure using the DEXA because they would not lie still. So there was one of people I worked with who was particularly good. She was a child whisperer and managed to get them to lie still, but it does need a lot of cooperation. So the precautions for the interpretation of fat and fat-free mass during these periods is really looking at how things change rather than just a snapshot in time. And adolescence would be one of the most difficult times to measure. Not only are the children more likely to say no, they might not want to take part in the research because they have to get their assent as well, but puberty causes rapid changes in both body composition, but also quite different changes in hormones and other risk factors that are hard to interpret. As one person said, they're all over the place at that time, so it might not be worth measuring some of the things that you'd want to during adolescence. And of course, once a woman starts having the menstrual cycle, it means a lot of things change over the month, and including body composition.
Okay. Thank you, Prof. The next question is, I'm surprised to see a very steep drop of the bone mineral density in the Pacific Islander or the Maori males, and also an increase in the BMD among European males. Is there any data, exercise, or genetic predisposition have influence on these observations?
Yes, well, the bone mineral density of Pacific and Maori is much higher than European. And I think that's related to their type of muscle, in that they tend to have more of the fast twitch muscle, which is larger and stronger. Not so good for running marathons, but excellent for playing rugby. European males, I'm not sure where that would come from. Well, the data I showed you was quite cross-sectional. It wasn't a longitudinal study. So in the past, all people did more manual labour, and that would have meant that their bone mineral density would have been increased. So it could be a generational effect rather than saying that it would drop in European males. It is very difficult to say for an individual what would happen. But certainly lifestyle and exercise, genetic predisposition have an effect on these. And there's recently been a gene discovered in Pacific and Maori, the CREP, which actually accounts for having a large body size but very low risk of diabetes and a number of other factors as well. So I think there's still a lot more we've got to find out there. But yes, lifestyle and exercise do have an influence for everyone, no matter what ethnicity they are.
Okay. So the next question is, as known, DEXA is a criterion method for body composition of children and adolescents. May I know what is the trend and potential for the use of DEXA among the pediatric population in the future?
Well, modern DEXA machines are so much faster than the old ones. It was 20 minutes a scan for the data I showed you, and now it's 5 minutes. That's for an adult. So for a child, it's even less. So much less difficult to do a whole body scan. And I think very interesting from the point of view of looking at the arms and the legs and the regions as well. And most DEXA machines now have software with prediction equations in them that seem to work very well for visceral fat as well in the abdominal area. So you get a lot more information than we used to from the DEXA scan. In fact, we're retrospectively analysing some of the scans to look at that visceral fat, because it is certainly much cheaper to do a DEXA scan than MRI or a CAT scan. So yes, I think it has a lot of future. And also the new DEXA machines will take people of much higher weights as well, because originally the original machine was 120 kilograms limit. Well, now it's 150, and above that you can get much bigger machines, because unfortunately that is the reality of obesity in many countries, that we're getting these very large extremes.
Okay. And the next question is, as there are so many different sophisticated bioimpedance analysis tools available, how do we know which device best suited to be used for screening at a population level? And what is your opinion on the use of body composition analyzers commonly available in portable weighing scales from Omron, Tanita, etc., for nutritional assessment or weight management in a small outpatient clinic?
Well, the cost of the equipment that you buy is a really important consideration, but so is the sensitivity and precision of it. So if you're monitoring individual people and you're always using the same machine and you keep checking it out on yourself to see whether you remain stable in your measures too, it can give you a good measure of change for an individual. But if it's more for research, I think that you should be looking for a machine that gives you the raw data as well, so you can write that down. Why I say that, and I have used the ImpediMed, which is an Australian bioimpedance single frequency meter, because at the time it was the cheapest. I was able to buy a number of them, but they gave the readings of resistance, reactive impedance, and phase angle. And because they're mathematically related, I could clean my data by checking that for a person that it mathematically solved for each one. The other thing that I wanted to look at more, but I haven't published on, is phase angle, because it seems that the phase angle is related to hydration of the person rather than directly body composition. And there's been a lot of publications about how low or high phase angle can detect risk and morbidity from certain diseases, including cancer. So when a person has cachexia or is starving, the phase angle might actually tell you more about impaired body composition than trying to just measure the body composition using prediction equations. But yes, try and get the best deal you can from the manufacturers. Question their precision and range of measure. Where did their prediction equations come from? Look up the publications that they got them from, see what the precision of the prediction equation was, and try and use the same model if you're doing a lot of measurements on everyone, and check that they are all giving the same reading. The ones that have multi-frequency do have their uses, but it's harder to find the prediction or validated equations to use for cell mass and those things. The software can give you a lot of answers, but it doesn't necessarily tell you if they're true or not. So again, you have to have other measures as well.
Okay. Thank you, Prof. Unfortunately, in interest of time, we could only take 4 questions. However, those questions that has been posted to us will be answered in a due course, and this will be linked through the Society website. And with that, thank you for all the questions, and thank you for Prof. Elaine for being here with us today. It was such a pleasure. And next, I will pass over the session to Professor Mahindran Appukutti, the Vice President of our society, for the closing remarks. Over to you, Prof. Mahin.
Hello.
Okay.
Hi, everyone. Thank you, Prof. Elaine. Thank you so much for the presentation, and thank you to all the viewers and Dr. Sazlina for the chairing the session, Prof. Chan and everything. I hope you all enjoying the session. This is a closing remark from me, and I'm showing some of the beautiful pictures of New Zealand. We have brought in Prof. Elaine from there, and I can't give you all so much places, but you can see the pictures from here, and then imagine Prof. Elaine with you, some of beautiful beaches there, some flowers and everything. Thank you very much, Prof. Elaine. It was a very interesting topic. You covered from the basic sciences up to the application. I believe everybody enjoyed it, and thank you so much to the your university for allowing you to be with us during your lunchtime there. And it's still morning for us in this part of the world. And I must thank my university, Faculty of Sports Science and Recreation, my faculty's management, the pejabat, the infrastructure and the infrastructure office for assisting all these services on the WebEx today, and the chancellery and the corporate communication for the YouTube that we were watching. A lot of members are viewing now, and also the international affairs for the help assistant in the IT and the WebEx platform. I must thank also UPM, Universiti Putra Malaysia, also alumni of the UPM. So thank to UPM, Research Center of Excellent Nutrition and Communicable Disease, and also Department of Nutrition and Dietetics, the Faculty of Medicine and Health Sciences for their support and help us to organize this international webinar on body composition. A very interesting topic, and we are all happy to know how learn. I believe all of you will enjoy the presentation in the Facebook. We will upload there in the Facebook and also in the YouTube channel, UiTM YouTube channel. Then you can have a look and recheck back your and counter confirm with your presentation of Prof. Elaine. And please, participant, if you are required to, you want the certificate, you must complete the feedback. Please scan the QR code here, and you complete the survey and submit within the 3 days, because its numbers are big and we have to do it what they call batch by batch. You will probably get it today, some of you maybe later tomorrow or day after, but this QR code will be disabled after 15 minutes from today, from now. So please, if you would like to have your certificate, which is signed by Prof. Elaine and also Prof. Chan, and this is the first webinar, and we would like to all of you to join us in the society and support the activity for future coming activities like what Prof. Chan have mentioned earlier. This will be a very interesting area to explore, and I believe that all of you will be get more insights on body composition, and we will look forward to meet Prof. Elaine in the next session. Very nice, very clear, calm. I feel like I was in New Zealand to listen to her. And that was a very environment that she brought it to us. And with that, thank you very much. I'll leave it this one for another couple of minutes, and then we will off this session. Thank you very much to everyone. Thanks to Prof. Chan, thanks to Prof. Sazlina, and thanks to all my team behind the screen. They have been running after the questions and answering some of the issues. And I must thank, because some are in charge of Facebook, some in charge of YouTube, to gather the questions and everything. Thank you very much, and have a pleasant day, and great sharing to all of you. Look forward to see you all again. Next, thank you very much.